Hello guys, this is lecture number 4 on JEE concepts, and in this video we are going to study about the swimming across the river problems. And believe me, after going through this lecture thoroughly, you will never gonna face any problem in solving any kind of questions related to swimming across the river. Just hold tight and listen very carefully. So I have divided this lecture into some key concepts which will help you deal in the questions related to this swimming across the river. So the first key concept is relative velocity concept. You must know about this concept in order to tackle this kind of problem. So first of all, you must need to know that velocity of man with respect to river is equal to velocity of man with respect to ground minus of velocity of river with respect to ground. This is a very important relative velocity formula, you can say concept, that you must need to know. And this diagram is basically depicting that. Here, this is our velocity of man with respect to river, and this is velocity of river with respect to ground. And thus, this is velocity of man with respect to ground. This thing you need to very carefully understand. So either via this or via this, I can write velocity of man with respect to river plus of this one, velocity of river with respect to ground, that is equal to velocity of man with respect to ground. So you can reduce this either via this or via this diagram. So these two things you must keep in mind. The other thing is, like it is generally given in the questions involving swimming across the river, this velocity of man with respect to river can also be called as velocity of man in still water. If something is given like this in the question, then you must need to understand that it is nothing but velocity of man with respect to river. Here still water means, and that is basically means that with respect to water, that is water is at rest. So that is the way of writing this thing, velocity of man with respect to river. Nothing to confuse about. Now let us move towards the another concept. This is the shortest distance covered by the swimmer. In questions involving this swimming across the river, it is generally asked like find the shortest distance covered by the swimmer. So wherever you see these kind of questions, then first of all you need to be very careful regarding the speed of current and the speed of swimmer in still water. So there are two cases I have discussed over here. The first case is when speed of current is less than speed of swimmer in still water. Like here in this case, this is what velocity of man with respect to water or speed of swimmer in still water, this thing. And this thing is basically speed of current or velocity of river with respect to ground. That is nothing but speed of current. So this is the first case in which I am letting this velocity of river with respect to ground lesser than velocity of man with respect to river or swimmer with respect to river. Okay. In this case, when you see from the ground over here, then with respect to ground, with respect to some observer on the ground, this swimmer must swim in this direction, 90 degrees. But velocity of swimmer or man with respect to ground, this must be that velocity of man with respect to ground. It must be in this direction, that is perpendicular to the horizontal, perpendicular to the speed of current. In this case, you can say that the swimmer is actually swimming in the shortest distance possible. And this is logical too, because we are concerned about this. And if you go or if you deviate anywhere from this straight distance, like either this or this or this or this or this, then obviously you need to cover greater distance than this perpendicular distance, because this perpendicular distance is basically the shortest distance out there is. That's why you need to cover this distance in order to have the shortest distance. And that's why when you see from the ground, then this swimmer must swim in this direction, making an angle of 90 degrees with respect to the speed of current. And for this, the velocity of this swimmer with respect to river must be somewhere over here, like this, at an angle with this velocity of river with respect to ground, at some angle, say theta. So that when you see from the ground, then this swimmer must travel in this direction, which is perpendicular to the speed of current. The second case is when speed of current is actually greater than speed of swimmer in still water. This is basically speed of river with respect to ground, and this is velocity of man or swimmer with respect to river. So here in this case, the second case, velocity of river with respect to ground is basically greater than the velocity of man with respect to river. And in this case, no matter how much angle you're going to take with respect to this speed of current or velocity of current, either this or this or this, you're never going to actually approach to move in this direction, that is perpendicular to the speed of current. So in this case of speed of current greater than speed of swimmer in still water, you're never gonna cover this shortest distance that was discussed in the case 1. Here the shortest distance will be different. I mean, if the observer is on the ground and you are trying to travel perpendicular to the speed of current, then this observer will never gonna see you do that, because in actual, if speed of current is more than the speed of swimmer in still water, then you will never go in a direction perpendicular to the speed of current actually. It's never possible to go. So in this case, you need to take the help of calculus by assuming some angle like over here theta or something like that, and then you need to find that shortest distance covered by the swimmer. It will be something like either this or this or this or this, but never this much straight. And whether this or this or this or this, you need to find with the help of calculus by assuming an angle theta and all those things that I'm going to discuss in the question in this very video. Now let us discuss another concept. And there is one more thing. It is only in these kind of situation, the situation I've discussed, like speed of current is greater than speed of swimmer in still water, questions like minimum distance that he has to walk on the other shore to reach opposite to the initial point will arise. We will see that the distance, suppose you actually tried very hard and at the best possible case you reached over here at this point, then the question will be asked like you need to find this minimum distance from here to here so that the swimmer will be at an exactly opposite point to its initial point, like over here where he actually started to swim. So these kind of questions will arise in this particular case only. Now the next key point is question will be asked like find the shortest possible time taken by the swimmer. So here in this case, the velocity of man with respect to river and the velocity of river with respect to ground, these two must be perpendicular to each other. That is, velocity of man with respect to river must be perpendicular to velocity of river with respect to ground. And if you keep like this, then you will gonna take shortest possible time in order to reach from this point A, say, to point somewhere here B, like this. And you can verify this also, because when you're gonna apply the equations and all, then some sine theta term will come at the denominator, and we need to find the shortest possible time, so the denominator must be maximum for that, and this maximum value of denominator will come only when theta is 90 degrees. Then only sine theta will be 1. That is the maximum value of sine theta. That's why this theta must be equal to 90 degree for the shortest possible time taken by the swimmer. Now the next key concept is like if the question is depicting from the point of view of swimmer, like in the question, if it is asked from the point of view of swimmer or it is given from the point of view of the swimmer, then it is always with respect to water. You need to understand that. You need to keep in mind this thing. Like suppose the question is asking like in which direction should he try to swim. So here the question is depicting from the point of view of swimmer. That's why it's with respect to water. Similarly, he keeps himself always at an angle of 120 degrees. This kind of language is there in the question. Then you need to be very clear that the question is asking with respect to water. Now the last key concept is like it's better to resolve the velocity components in the horizontal and vertical direction rather to apply vector formula, which may becomes lengthy to solve. Like if you apply the vector formula under root of a square plus of b square plus 2ab cos theta, or the angle formula like b sin theta upon a plus b cos theta, then it might be the case that the question will become too lengthy to solve. That's why the easy thing is you better resolve the velocity components in the horizontal and the vertical direction. Like here in this case, suppose this is velocity of man with respect to ground, and this is velocity of river with respect to ground, and the angle is theta, which is obtuse here in this case, just suppose. So it's better that you divide this Vm with respect to g in this vertical and in this horizontal components, and then this component and this component, just add these two, and here we are only left with one component in the vertical direction. So from here you will get a resultant component in this direction and in this direction, and just now apply. Suppose this is a and this is b, then you just need to apply over here under root of a square plus of b square. And also for angle, if suppose this is alpha, I am supposing, then tan alpha will be equal to b upon a. So just try to make things easier than to complex things out. So these are some of the very important key points that you need to be aware of while solving or tackling the question of swimming across the river. So now let us move towards the question. And this question is going to cover all of the doubts, all of the points that I have discussed over here. And this question is taken from the H.C.Verma Volume 1 Physics, question number 47 and 48. So the question is, like a swimmer wishes to cross a 500 meter wide river flowing at 5 km per hour. The river is flowing at 5 km per hour. Means what? This is nothing but velocity of river with respect to ground. And that is what? 5 km per hour. And this river is how much wide? It's 500 meter wide. So this is meter, this is kilometer. Just remember these things. You need to be very clear about the units. Otherwise, you're going to make the blunder. And then your options will never going to match. So either I can write here half kilometer. It's better. Now his speed with respect to water is 3 km per hour. Velocity of man with respect to river or water is 3 km per hour. Now see here. The velocity of current, which is 5, and the velocity of man with respect to river is only 3. So this 5 is greater than 3. So what kind of situation is this? When the swimmer will unable to take the shortest distance, or I can say that when the swimmer will unable to travel at an angle of 90 degrees with respect to the speed of current when an observer from the ground is observing. So this is very clear. I have already discussed. Now let me read ahead. If he heads in a direction making an angle theta with the flow, like suppose here, this is velocity of man with respect to river, and if he is heading at an angle theta with the flow, suppose this is theta, find the time he takes to cross the river. Okay, we need to find the time which this man takes, or this swimmer takes to cross the river, and this is angle theta. So I know that this angle is what? 90 degree. So this will be theta minus of 90 degrees. It's obvious. And this is how much? This is 3. So now see, this is 5, this is 3, and this is theta. So what I'm going to do over here, I'm going to divide this velocity into the two components without actually going to apply the formula of resultant for vectors. Okay, so this is 3, this is theta minus of 90. So this in vertical direction, it will be 3 cos of theta minus of 90. Okay. And in this horizontal direction, like here, 3 sine of theta minus of 90. Okay, and here it is 5. So I can write this minus of this net in this direction, x direction. What? 5 minus of 3 sine of theta minus of 90. That is net in this direction. So now we are having two components, one in the x direction and one in the y direction. That is horizontal direction and vertical direction. So in the vertical direction, we are having this much velocity. Vertical direction velocity is what? 3 cos of theta minus of 90. In the vertical direction, there is only one component of velocity. Otherwise, the different component is, the other component is in the x direction. So when that swimmer is basically moving and we are asked to find the time he takes to cross the river, then only this velocity component is responsible for this swimmer to move in the y direction, which basically takes him from this point, say A, to this point B. Only this velocity is responsible. And the distance from point A to point B is what? Half kilometers. So we are having the velocity, we are having the distance. Let us find the time. Because here see, the x direction velocity is not responsible in order to take this swimmer from point A to point B. It is only the y direction velocity which is basically responsible. That's why I'm taking only the y direction velocity for calculating the time he takes to cross the river. So we know that time is equal to distance upon speed, or say velocity. So here distance is half kilometer and velocity is 3 cos of theta minus of 90. Now this theta minus of 90 can be written as cos of 90 minus of theta directly. Why? Because this cos is an even function, which means cos of minus of theta is basically cos theta, but not with the case of sine. In case of sine, this will be a negative of sine theta. So this can be further written as half upon 3 cos 90 minus of theta, and that will be equal to 1 upon 3 multiplied by 2 is 6 sine of theta, because cos of 90 minus theta is sine theta. This much hours basically, because we were solving in terms of kilometer per hour. Or this can further be simplified to minutes. How? By multiplying with 60, like 1 upon 6 sine theta multiplied by 60, and this will be 10, and that is equal to 10 upon sine theta. This is the answer, this much minutes actually. So the time taken by swimmer to cross the river is 10 upon sine theta in minutes. The next question is, find the shortest possible time to cross the river. So from here, it is actually direct that we are already having this time, that is 10 upon sine theta, and now we want the shortest possible time. So for shortest possible time, as I have already told, that the sine theta is gonna come in the denominator. So this denominator must be maximum for this time to be minimum, and for this denominator to be maximum, this theta must be equal to 90 degree, because sine 90 is 1, which is the maximum value of sine theta. So at an angle of theta is equal to 90 degree, this time is gonna be the shortest, and that will be equal to t is equals to 10 upon sine 90, that is equal to 10 minutes. That is the answer. So for the shortest possible time, you can also see from over here that this theta must be equal to 90 degree. That is, this velocity of man with respect to river must be over here, like vertically, this one. And then only the speed of current and the velocity of man with respect to river is gonna perpendicular to each other. That is, theta is equal to 90 degrees. So the minimum time, like t minimum, is equal to 10 minutes. Now another set of question. From here, actually it is question number 48 in H.C.Verma, but it is linked to the question number 47. And the question is, like the man has to reach the other shore at the point directly opposite to his starting point. We already know that this man is starting from this point A in a direction, say at an angle theta, like this. But this man wants to go at a point directly opposite to this point A, that is actually at this point B. But we have already discussed over here that the velocity of current, the velocity of river with respect to ground, is greater in this case than the velocity of swimmer with respect to river. That's why with respect to an observer on the ground, this man will not be able to go at a direction perpendicular to the speed of current or speed of river with respect to ground. That is in this direction. It's not possible because of this condition. What is possible is that at its best, suppose this swimmer will be able to go at some point over here, say this point C, so that this BC, that is this distance BC, will be minimum. So that is the best possible scenario in this situation, where 5 is greater than 3, or velocity of current is greater than the velocity of man with respect to river. And that's what the question is. If he reaches the other shore somewhere else, suppose at point C, then he has to walk down to this point B, and find the minimum distance that he has to walk, because H.C.Verma sir already knew that this 5 is greater than 3. That's why it is not possible for this swimmer to just reach directly at point B, and that's why this swimmer will gonna reach at some point C, and from there he has to walk to point B. So we need to find this minimum distance of BC. So let us find out. Actually, we already know the time. Supposing at an angle theta, we already know the time, that is 10 upon sine theta, general time, in order to reach from this shore to that shore, while considering the velocity in the y direction, which is 3 cos theta minus of 90 degrees. Now for finding this distance BC, actually we need to take into consideration this velocity, that is the velocity in the x direction, because that is only responsible for this swimmer to move in the x direction, in this direction, horizontal direction. So just take this velocity now, x direction velocity, which is 5 minus of 3 sine of theta minus of 90 degrees. Now this theta minus of 90, if I'm going to write it 90 minus of theta, then it will be a negative sign, and that negative and this negative will become positive, sine 90 minus of theta. And this sine 90 minus of theta can be written as cos of theta, that is velocity in the x direction. And we already know the time, 10 sine theta, because the time taken in the y direction, in the vertical direction, will be equal to the time taken in the horizontal direction. So from that we can find this distance BC, velocity multiplied by time, that is 5 plus of 3 cos of theta multiplied by 10 upon sine of theta. But again, this is in kilometer per hour, but this is in minutes, as I have already converted. So just divide with respect to 60, then that will be 6 sine theta. So this is nothing but 5 plus of 3 cos theta upon 6 sine theta. that is equal to distance BC. But we need to minimize this distance BC. So again, we need to take the help of calculus. So let us move further ahead. Okay, so this must be minimum. For that, d of theta of dBC must be equated to 0. That will be 6 sine of theta multiplied by this 5 will be 0, and this minus of 3 sine of theta minus 5 plus of 3 cos of theta multiplied by 6 sine theta, that is cos theta. The differentiation of sine theta is cos theta upon 6 sine theta whole square. That must be equated to 0. That will be equal to minus of 6 times 3 is 18 sine square theta minus of, this is actually within the bracket, 6 multiplied by 5 is 30 cos theta. This again minus 6 multiplied by 3 is 18 cos square theta upon 6 sine theta whole square. That must be equal to 0. Now this 6 sine theta will never be going to infinity, so that will make this whole as equal to 0. So this can be neglected. So now I'm writing over here, this minus 18 and sine square theta plus of cos square theta is actually minus of 18 multiplied by 1 minus of 30 cos theta, that is equal to 0. So this is actually minus of 18 upon 30, that is equal to cos theta. This is actually 6 times 3 is 18, 6 times 5 is 30. So cos theta is equal to minus of 3 upon 5. So sine theta will be equal to under root of 1 minus of cos square theta, and if you calculate this, then you will get 4 upon 5. So now we are having cos theta as minus of 3 upon 5 and sine theta is equal to 4 upon 5. These two things now we are having for the minimum value of distance BC. So we need to put this value of cos theta and this value of sine theta over here in this case in order to get the minimum distance BC. So let us put this 5 plus of 3 cos theta is what? Minus 3 upon 5 upon 6 multiplied by sine theta, that is 4 upon 5. That will be equal to 5 minus of 9 upon 5 upon 24 upon 5. That is equal to 16 upon 5 multiplied by 5 upon 24. This cancelled out. 4 times 4 is 16. 4 times 6 is 24. 2 times 2 is 4. 2 times 3 is 6. That is equal to 2 upon 3 kilometers. Minimum distance of BC. That is the answer. So 2 upon 3 kilometers is basically the minimum distance that this swimmer has to walk in order to get from point C to point B, that is directly opposite to the starting point of A. So this is how you guys need to proceed in case of swimming across the river problems, and believe me, this is one of the tough questions that is given in the H.C.Verma book. But there are some other good questions too in the same book, or you can refer to any other book for some good questions. And if you feel any difficulty in solving those problems after going through this lecture or after going through the points discussed in this lecture, then feel free to contact me by going through the link given in the description below. So till then, thank you guys.